Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 5.4 Composite Figures. What are we going to be learning? Well, by the end of the lesson, you will be able to calculate the area and perimeter of a composite figure on the coordinate plane. Composite figure, basically you're taking a couple of different shapes and you're combining them together to make some weird looking shape slash figure. Why is this important? Well, let's think about it. Your house is not like a square or a rectangle, and to find the area of it, somebody had to do area and perimeter of your home using composite figures. So to understand area and distance around a figure that is not a shape you have a known formula to solve, this can be very helpful. How will you know it? Well, you'll know you've mastered it when you can find the exact or estimated area or perimeter of a composite figure.
All right, so let's go ahead and get started. First, what is a composite figure? It's a figure formed by combining familiar shapes, and the familiar shapes we're going to be looking at are rectangles, triangles, and semicircles. You're going to do this by adding your own vertical and horizontal lines to break up a composite figure. So you're going to use the coordinate plane that we give you to create your familiar shapes. So go ahead and fill in your blanks to make sure you're ready to move on to the next screen. Okay, so the formulas that we need to know. So first, finding area is determined by dividing the figure into familiar shapes and using the formulas associated with those shapes. So again, you're going to break these shapes up into any of these three that you see. We know that a rectangle is going to look like this. To find the area of a rectangle, it's going to be the base times height, or length times width, however you want to think of it, where this horizontal side would be the base or length, and the vertical side would be your height or your width, depending on how you want to think of it. Because we're using the coordinate plane, the triangles that you're going to be seeing, they're only going to be right triangles. So I'm going to go ahead and add that in. I should actually add that into this picture as well. It's always going to be half of base times height. Our base is going to be this horizontal side, and the vertical side is going to be our height. Remember, you can also think of that as base times height all divided by 2, depending on how you were taught. And then lastly, you're not going to have a full circle in a composite figure. You would only have semicircles. You would calculate this by finding the area of a circle and taking half of it. So you would need to know your radius length, and then multiply that by itself, then multiply it by pi, and then divide it by 2, or take half of it. So those are the formulas you are going to need to know for finding area of a composite figure. We're also going to be doing perimeter. Perimeter is determined by dividing the figure into familiar shapes and finding the side lengths of all the shapes, then find the sum of the exterior sides. So we're only going to be looking at the outside of the composite figure. Again, the shapes that you're going to be looking at are these. If you have a rectangle, you're only going to be dealing with vertical and horizontal side lengths, so you can just count those. But when you start dealing with semicircles, you would need to find half of the circumference, which would be, I don't need that dot there, half of pi times the diameter, so from side to side.
Or you could also say 1/2 times pi times 2 times your radius, right?
Correct. And then half of 2 would cancel, so it's really just pi times radius.
Yes.
All right, so over here, I'm just basically taking into account what we went over in lesson 5.2, I believe. Remember, Pythagorean theorem and distance formula are very closely related, so it's really your comfort level. Distance formula, you would need to know these two coordinates, which you obviously will. And then if you choose to do Pythagorean theorem, this would be your, not your D, A, B, and then of course this side would be C. It's up to you which one you prefer using. You do not use both. You use one or the other, whatever your comfort level is. All right, so let's go ahead and get started. So you guys have just two figures, and you're going to do two things with them. You're going to find area of the composite figure and then perimeter. So we're going to start with area. So the first thing we need to do is break this composite figure up into more familiar shapes. So what I always suggest to my students is that you do this in color, first of all. Second of all, you're going to look at the diagonals. So the first diagonal that I am seeing is diagonal AD. Okay, where are you, diagonal? There we are. And then you're going to treat this almost like a multiplication chart. You're going to connect the endpoints vertically and horizontally. So to get to D, you know A is going to come down. And to get to A from D, you're going to go left. And you can see that you've formed a right triangle right there. So that is going to be the first shape that you are going to be finding the area of. Now, we have another diagonal. We have diagonal DC. So I'm going to do that in a second color. And again, whenever you have a diagonal, you're going to make a right triangle out of it. So from D, you're going to go left until you're directly above C, and then you're just going to go straight down. We have one more diagonal here, diagonal BC. Get the color I want for that. I did pink. So B to C is a diagonal, so we're going to make a right triangle right here. And what that's leaving me with, what it will always leave you with, is just vertical and horizontal sides. So you can make a rectangle or combination of rectangles with the space left over. I'm actually going to make this a little thinner so you can see the two colors. There, there. All right, I have some additional points based on how I made my shape, so I'm just going to add in letters so that I can actually name all of my shapes when I find the areas here. So this first one, we have two vertices named A and D. I'm going to go ahead and name this third vertex that's right here. I'm just going to name it E because that's the next letter on the alphabet. Right here we have DC, and then we have this third vertex that doesn't have a letter. So I'm going to name it F. And then we have this one right here that does not have a name. We're going to go ahead and name it G. So that way when we go ahead and work them out over here to the right, we have names for each of them. So our first triangle, we have ADE. We're going to have to find the base length and the height of this triangle to find the area. Notice that the increments are in twos on this graph. So if I go from D to E, or E to D, count by twos. So we're going 2, 4, 6, 8, 10, and 12. So the base length is 12. Your height, we're going to go from E to A. So we're going to go up to 4, and then halfway would be 1. So 2, 4, and 5. So to find the area of this triangle, we're going to do half of base times height, which would become half of 12 times 5, which gives me an area of 30. We're going to do the next one. Over here we have triangle DFC that I'm going to find the area of. So if I calculate the base, which is our horizontal side, that's going to be just 2. Our height is going to be our vertical side, so that's going to be 2, 4, and then halfway giving me 5. So a base of 2 and a height of 5. That's going to give me half of 2 times 5, which is just 5. We're going to follow through and do the same for the next two shapes. We have one more triangle. We can see that the base from B to C, we're going to go 2, 4, 6, 8, 10 for our base. And then our height is going to go from here, we're going to go down 1 because it's just halfway between the boxes. So we have a base of 10 and a height of 1. Half of 10 times 1 is also an area of 5. So that is our three triangles. What's left over is this rectangle BEFG right here. Rectangles are the easiest. You just need to calculate your base and height, or length and width. We know that B to G is 10. We already calculated that. And then our height is B to E, which would be 4. So we have 10 times 4, which is an area of 40. So we have our 4 individual areas. Now we just need to take those 4 and add them up.
Now, you could have divided this shape up into many more smaller composite shapes. Now, Would you have gotten an incorrect answer? Not if they were divided up into correct shapes and you did all your math correctly. You would just have to add more numbers together. Your goal with doing composite shapes is to divide your big figure up into as few as possible figures as you can.
All right, so that is how you guys are going to calculate area. You're going to split these up into our shapes that we're familiar with, and then you are going to simply find the area of the individual shapes and then add them all up. So our next task is with this same shape, we are going to calculate the perimeter of our shape. So I'm going to go ahead and copy in or paste in my individual shapes. You guys already have that done on yours. All right, so now we need to find side lengths. So the first side that we have here is AD, and AD is a diagonal length. So we need to do distance formula or Pythagorean theorem. I tend towards Pythagorean theorem with this one more because we already have the right triangle drawn for us. So we know that C is going to be equal to the square root of A squared plus B squared based on our 5.2 lesson. So you already know A and B have lengths of 12 and 5 because that's what we counted already when we did area. Remember, E to D was 12 and A to E was 5. So we're going to find the square root of 12 squared plus 5 squared. Again, that's C is equal to the square root of A squared plus B squared. That's going to give us a square root of 169 when you work it out, which has a length of 13.
And I know that because I know my perfect squares at least up to 15.
Perfect. So I'm going to go ahead and actually write that out here. All right. Next, we're going to go ahead and do, I'm just going to go around. It's best if you just go around your composite figure. So I went here. Now I'm at D. I'm going to go to C. So this is another right triangle. So we can do Pythagorean theorem again. So we know C is equal to the square root of A squared plus B squared. Well, I know my base and height from the area was 2 and 5. So I know my A and B are 2 and 5. So we need to figure out what is the square root of 2 squared plus 5 squared. Well, it's going to be the square root of 29. As many of you have discovered, we are not going to figure out the square roots yet. You do not want a decimal answer here because you don't round until the very end of a problem. So we're going to just leave that as the square root of 29 for right now. So now I'm at C. I'm going to go to B. This is a right triangle with A and B lengths of 1 and 10 because we already counted that. So we need to figure out what is the square root of 1 squared plus 10 squared. It's going to be the square root of 101. We're going to leave it just like that. I changed my colors.
I'm changing my colors.
Square root of 101. And then what's left is just some easy math because we have to go from B up to A. Well, that's just a vertical side. So we can just go ahead and count that up. So from B to A, we're going to go up to 4, 6, 8, and then halfway. I'm sorry, AB is actually 9, not 10. So I want to fix that.
The biggest thing we need to be careful of is that we need to remember we're counting by twos, and because we went up half a block, that's only 1. So watch very carefully the labels of your coordinate planes and how they're counting.
So this is a quadrilateral, so to find the perimeter, we are simply going to put in our calculator 13 plus square root of 29 plus the square root of 101 plus 9. So we should be getting 36.44 units for our answer for the perimeter of this composite figure. And that is how you find area and perimeter of a composite figure. We're going to go ahead and do the same thing for our next shape. Oddly enough, our next shape looks more complicated, but it's actually a little easier because you only have 2 diagonals. So we're only going to have to do Pythagorean theorem and area of a triangle, all that just twice rather than 3 times like we did in this problem. So the first thing we need to do is we need to determine our triangles. That's always the first place we want to go, is where are our triangles. So looking at this, the first thing I'm seeing is that we have side BC. So I'm going to go ahead and do that. And then vertically and horizontally, I'm going to make triangle BCD. The other triangle that I see is going to come down here at side GH. GH is diagonal, so I'm going to make a right triangle right here. Now, what's left over, it's like a backwards block L looking shape. Again, while that may look complicated, it's actually not bad because it's just a combination of rectangles. It's up to you how you want to make that rectangle. I personally, for whatever reason, I personally went long ways. So I am making this my rectangle that I chose. As Mrs. Nett said, you don't have to do it this way. This is just how I happen to do it. And what that leaves me with is this, it's actually a square right here.
Again, make sure you're watching how that coordinate plane is numbered and where you're drawing your lines, because you may have to draw those lines halfway through a square, which makes it half of the value that's being numbered on your axes.
So just to make sure our shapes all have names, my point B kind of got blocked, so I'm just going to go ahead and write it again here. And then we have one additional point right here, which I am going to name as I, just so I can name my shapes as I'm working them out over here to the right. So now that we have our 4 shapes, I'm going to ask you guys to pause this and go ahead and calculate your 4 areas, and then add them up to get your total area. Okay, so hopefully what you came up for the first one is that you have a triangle that is a base of 10 and a height of 6. We have 2, 4, 6, 8, 10, and 2, 4, and 6, so an area of 30. Our other triangle you should have gotten has a base of 7 and a height of 4, giving me an area of 14. Our 2 rectangles, if you chose to do the same 2 as me, we have rectangle AJIG, which is going to be a base of 7 and a height of 14, giving me an area of 98. And then lastly, my square right here, BEFG, has a base of 6 and a height of 6, so we have an area of 36. Add those all up, you should have gotten an area of 178 units squared. I'm going to use these same 4 shapes, obviously, since you guys are sharing this picture for the 2 problems, so I'm going to copy it. And I'm going to paste it. Technology is so nice.
It is.
Except when it doesn't drag what I want it to.
Or when it just doesn't work.
Yes.
So sorry.
I know. There we go. Oh, I didn't take one side.
That's right. While you're doing this, I'm coloring my pictures.
Oh, it looks so nice.
So my notes look pretty.
All right, so we're going to go ahead and find the lengths of all of these sides. I'm going to just choose to start at
Some point.
Where did I start?
Pick a point. We're going to start.
I think I started at A.
We are starting at
A. So we're going to count A to J. So again, my increments are in 2s. So if I'm halfway, that's 1. And then 2, 4, 6, so 1 and 6 makes AJ, a length of 7. Then I'm going to go J to H down here. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, and 18. So J to H has a length of 18. Then I have a diagonal. Remember, diagonal is going to be Pythagorean theorem or distance formula, depending on what you like. We know that this triangle had a base and height of 7 and 4, so we need to calculate 7 squared plus 4 squared and square root it. We get a length of square root of 65. Then we're at G to F. So G to F is 6. That was the base of our square. Then the height of our square was also 6. So F to E was 6. Now for the first time we actually have to count this little piece. This was not part of a shape. D to E. We're halfway, so here's 1. And then 2 more is 3. And then 1 more. So we know that D to E is actually 4. Then we have the height of our triangle, so we have 2, 4, 6. And then right here, we have another diagonal that we need to find the length of, so I'm going to use the right triangle to do this. We know this triangle had a base and height of 10 and 6, so 10 squared plus 6 squared is 136. So therefore, the length of CB is going to be the square root of 136. Lastly, we have to count how big is B to A. Well, it's 2, 4, 6, 8. So we're going to take all of that together. Sorry it's so tiny, but there were a lot of sides there to calculate. You do have the 2 square roots. Make sure when you are plugging those into your calculator, if your calculator puts you under the square root, make sure you arrow out of it. You should be getting approximately 74.72 units in length around this composite figure.
Imagine if your house was shaped like this.
Could be.
Yeah.
So hopefully you guys feel confident in your ability in breaking these shapes up and then calculating the perimeter and area of a composite figure. If not, you know where to find us by now, hopefully.
I hope so. But hey, Mrs. Weichel.
Hey, what was that?
Why are mountains so funny?
Why?
Because they're hilarious.
Thank you for joining us. We have one more lesson to give you for Chapter 5.
See you in 5.5.